To send my greetings to all the students and give you the confidence that continue preparing. As I've always told you, we have the hope that schools are going to open on assumption that all the SOPs that are supposed to be fulfilled will be fulfilled by all the schools. And for us, we are always ready to receive you back and continue doing our thing as we have always been doing it. Without wasting time, I want to go through the two numbers I left last time. We were here for Physics 2 2 weeks ago, and I want us to go through those two numbers. For those who tried them out, you will verify your answers, and thereafter we shall be going through other questions as we wind up the prism refraction of light. Enjoy the lesson. Let us proceed. Yeah, one of the questions that we left behind, I'm not going to write the statements. I am sure you have the statements. I'll simply interpret them. One of the questions was asking us to calculate the angle of emergency, and they called it I. They called it I. Remember, we are looking at grazing, incidence, and grazing emergency cases. So light was incident. When light is incident at 90 degrees, it is incident on the first face. If we put this as a normal, this is our normal line. They told us that the angle of the prism is 60 degrees. This angle is 60 degrees. This light is refracted as indicated. We have another normal here, and it emerges out. It emerges out, say along this line. This angle in the question was called I. It was called I. From the knowledge that you already have, if we extrapolate this, we are aware this is still the refracting angle of the prism. And we are also aware that this is the critical angle. We shall call this R. We shall call this the angle of refraction at this face. We were also given that the refractive index of the prism is 1.5. So using refraction on the first face, considering refraction on the first face, I can even choose to call this A, B, C, and I say on face AB, N, and using N sin I is a constant. Of course, this is air, this is a prism. So the refractive index of air times the sine of I will be equal to the refractive index of the prism times the sine of C. I is 90 degrees. N is 1.5, and NAM is 1. So 1 times the sine of 90 becomes equivalent to 1.5 times the sine of C, which implies, remember that sine of 90 is 1, which implies that the sine of C would actually be 1 out of 1.5. And from here, C would be the arc sine. 1 out of 1.5 is the same as 0.6 recurring. So this is the same as 0.6 recurring because this gives us 3/2, which is 2/3. And therefore, our C becomes approximately 41.8 degrees. Remember, our main aim is to find the value of the emerging angle I. To find the value of the emerging angle I. Now, from the angle geometry, if we have C plus R, we shall get 60. That is the sum of two interior angles is equal to an exterior angle. I will say that but R plus C is equal to 60 degrees, implying that R is equal to 60 minus 41.8, and this will give us a value of 18.2 degrees. So if we consider refraction on the second face, refraction on face BC, if we consider refraction on face BC, n of the prism times the sine of R should be equal to n of air times the sine of I, which I this time round is what we are looking for. Remember, our R is 18.2 now, so our 1.5 times the sine of 18.2 degrees will be equal to 1 times the sine of I. Therefore, the sine of I, when you compute there, should be able to give you an angle. The sine of I is 1.5 times the sine of 18.2. If you use your calculator, the value of I that we are looking for is the arcsine of this computed, and that I, when you compute, will be obtained as approximately 27.9 degrees. Approximately 27.9 degrees. This question also required us to find the deviation. It required us to find the deviation, so we shall proceed to now look for the deviation. To find the deviation, recall that we have the deviation here is given by this angle, which I'll call D1, and the deviation here, if we extrapolate, it is given by this angle, which we shall call D2. So on face AB, my D1 would be equal to I will just put it right, will be equal to 90 minus C, because this angle is supposed to be equal to this angle here, C plus D1. So D1 becomes 90 minus C, and since we have the value of C, it is possible that we shall get our deviation as 90 minus our 41.8 degrees. Similarly, on face BC, our D2 is going to be equal to I minus R, and our I is 27.9. Our R is 18.2. So total deviation required will be the sum of these two deviations. The sum of D1 plus D2. And this gives us 90 minus 41.8 plus 27.9 minus 18.2. When we add up these values, or when we subtract them, we should be able to get our deviation D as 9.48.2 plus 9.7 degrees, and this will give us 0.975. So our total deviation gives us the angle as 57.9 degrees. Our total deviation is 57.9 degrees. That brings us to the completion of that first number. The first number, which I had left with you. That first number is now fully complete. They wanted us to find the angle of emergency I, which we've been able to find at this stage. And they also wanted us to find that total deviation, which is obtained by getting D1 and D2 and adding them. Actually, this would be the point where our total deviation would appear, D. We shall be shortly going to the next number that was left, that was number 2. We shall be shortly going to the next number that was left. But let us allocate time for those who are capturing this solution, for those who are making corrections here and there to capture the corrections. For those who are marking themselves right, I am sure you are glad that you got everything right, those who did. And this is the time to check yourselves out. And that's why we normally go through numbers that we leave behind as an exercise. I'll allow 2 more minutes and we shall go to the next number. 2 more minutes and we shall go to the next number. Yes, I think we can now move on to the next number. And allow me erase the interpretation for this number so that we can prepare. Our next number was still on prism refraction. Remember, we are looking at prism refraction. And we had a question that was saying the refracting angle of a prism is 60 degrees. So we still have a prism, this time round, whose refracting angle is 60 degrees, 62 degrees. This angle here is 62 degrees. And the refractive index for yellow light is 1.65. R refractive index for yellow light is 1.65. A is 62. What is the smallest angle of incidence for yellow light which is transmitted without total internal refraction? Now, they want us to find the smallest value of the angle of incidence. If this is our normal, and we say light comes in at an angle of incidence alpha, alpha is what they're asking us to find. What is the smallest angle of incidence for yellow light which is transmitted without TIR? TIR is total internal refraction. Without TIR implies that this light, upon refraction here, will not move out without total internal refraction. It implies that on the second phase, the light will graze here. So this is the question approach, that the smallest angle of incidence, which I'm calling alpha, that will allow light not to be totally internally refracted, is going to be obtained by considering that light will graze here, implying that the angle of refraction here and the angle of emergence is 90. The angle of refraction here is definitely going to be the critical angle. And therefore, this, if I call it R, it can be determined. And similarly, compared to the first example we have just looked at, that the sum of R plus C, according to my interpretation here on my sketch, is still equal to 62 degrees. The value of C is the same as the value we got in the method is the same, but because the refracting angle is different, it is going to be different. And because the refractive index is also different, it's going to be different. So, using, this is air, this is the prism, and the refractive index here is 1.65 because we are looking at the refractive index of light, which is yellow light. So we shall use n sin I on the first face. I can call this P, Q, R. If we consider refraction on the first face, considering refraction on face QR first. If we consider refraction on this face, we shall have that n of yellow light times the sine of the critical angle should be equal to n of air times the sine of 90 degrees. N sin I is a constant. We are using n sin I as a constant, and therefore 1.65 times the sine of C should be equal to 1 times 1, which implies that the sine of C is 1 over 1.65. And this further implies that the value of C, when you compute, the value of C will be 37.31 degrees. 37.31 degrees. Our C is 37.31 degrees. But we have already seen that R plus C is 62. This implies that R is 62 minus 37.31, which will give us the value of R upon subtraction as 24.9.69. R is going to be 24.69 degrees. So now that we have R, we can use n sin I again on this face. Refraction on face PQ, refraction on face PQ will now give us Nm, the sine of alpha which we want, should be equal to n of yellow light, the sine of R, which is 24, the sine of 24.69. Our interest is alpha, so 1 times the sine of alpha will be equal to 1.65 times the sine of 24.69 degrees. If you compute to get the value of alpha, our alpha will be equal to the arc sine of 1.65 sine of 24.69 degrees. And when you compute using your calculators, that should be able to give you a value of 43.57 degrees. So we can confirm and say that the angle of incidence, the smallest angle of incidence, is 43.57 degrees. The smallest angle of incidence as required by our second number is that. I would like to remind you that there are several other numbers I left behind to be picked from the question bank book. And there are quite a lot of more questions you can get from the question bank book. I want to request you to do yourself a good service by getting more numbers there and try them out. I'll be putting on our next question as you capture any corrections here or as you tick your answers. We are looking at this. We are looking at this. We are looking at this working, and finally that angle there. Our next question, which I will call another example, is going to be written here. Our next question to try out, I am going to write it over there. A prism of refracting angle 60 degrees has refractive indices 1.515 and 1.529 for red and violet light respectively. That means the first value is for the red light and the second value is for the violet light. They are saying when light is incident on one face of the prism, it undergoes minimum deviation. It undergoes minimum deviation. They are telling us to find the angle of incidence for the white light and the angle of emergency for the violet light. That is our next question for a while. That is our next question. Important to note as we prepare to go through the solution for this number, important to note is the condition for minimum deviation. The candidate must be able to know the condition that goes with minimum deviation. We are all aware that when white light is incident on a prism, the prism disperses this light to form what is called a spectrum, and what an ordinary person knows as a rainbow. The prism separates white light into 7 colors that you usually see when it is threatening to rain. Not on all days is it visible, but on most days we usually see that. So as we prepare to start on our solution, we shall have a prism here. We shall have our white light incident. This is white light. We shall create our normal here. Assume this is our normal. And this white light is going to be refracted to give the red light over there and further refracted as it emerges out. This is red and this is violet. They have told us that this angle is 60 degrees. And they have given us the refractive index here for the red light as 1.515 and the refractive index here for the violet light as 1.529. They are telling us to calculate the angle of incidence for the white light. Now, if we let this angle be I, that is the angle we want to look for. Take note that the angle of refraction for the red light would be this, and the angle of refraction for the violet light would be this. It implies that since we know the condition for minimum deviation, we are going to say, since we know that refractive index at minimum deviation is given by the sine of the minimum deviation plus the refracting angle divided by 2 over the sine of the refracting angle divided by 2. For emphasis, I can say I is given by d mean plus A over 2, and R is actually given by A over 2. We looked at all these derivations, and if you have been following all our lessons from the start on prism refraction or refraction of light through the prism, you must be in the know of how you can actually get I as d mean plus the refracting angle divided by 2 and r as a over 2. So if we use this expression, we should be able to find the value of I. Our interest is look for the value of I, and we shall begin. I have already said we are aware, but I can re-emphasize that refractive index of red light has been given as 1.15. Refractive index of violet light has been given as 1.529. Refracting angle of the prism has been given as 60 degrees. So if I apply this for the red light, for red, that's part 1. I will have my 1.515 as my refractive index being equal to the sine of d mean plus the A, which is 60, all over 2 over the sine of 60 over 2. I want to get the minimum deviation, and I will proceed to note 1, the sine of 30 is a half. 60 divided by 2 is 30. So I'll have my 1.515 and multiply it by 0.5. If I do what one would call a cross multiplication, this would multiply through there, and this would be equal to the sine of d mean plus 60 all over 2. This implies that d mean plus 60 divided by 2 is going to be equal to the arc sine of 0.5 times 1.515. This implies that if I take the sine inverse of this product, I would get this, the equivalent of this in degrees here. And when you use your calculators, you will discover, I will be able to remove the question so that I proceed, but I can say that this is the arc sine. When you compute this, it gives you 0.7575. 0.7575. Since we have all the information we need, I can remove this question, assuming that it had been captured. Remember, I always tell you the major function of the brain is to forget. The reason I always tell you to always either take a picture of the question before you begin solving it. It implies that if I do the mathematics here, I have d mean over 2 plus 30 degrees being equal to the arc sine of 0.7575. When you use your calculators, our d minimum or minimum deviation over 2 will be equal to this angle. That angle will be obtained as 49.24 degrees. This is 49.24 degrees. So it will be 49.24 minus 30. If we take away 30, we can therefore now say our minimum deviation will actually be equal to 2 times this difference, which is 19.24. And when we compute this, we can say finally that our minimum deviation will be obtained by getting 8, 4 point. This will be 8, and this will be 3. The value for the minimum deviation will be approximately given as 38.48. This is 8, this is 4, this is 18, keep 1, 3. That is the minimum deviation. But they are asking for the angle of incidence. They are asking for the angle of incidence. So we need to recall that since at minimum deviation, at minimum deviation, I already told you that the value of our angle of incidence at minimum deviation, our d mean, is always obtained when 2 times the angle of incidence minus the refracting angle is possible. This is where we get this. If you make d mean the subject, you'll get from here, you'll get that. This implies that the I, which is here, if made the subject, will be equal to d mean plus A over 2, which I earlier shared. So our I, the value of I, therefore will be equal to our 38.48 plus our A, which is 60, everything divided by 2. This will give us 98.48 over 2, and this will give us 49.24 degrees. This will give us 49.24 degrees, which we actually had right over here. So our value of the angle of incidence is therefore going to be this. So the angle of incidence for red light is 49.24 degrees. The value of the angle of incidence I for red light is going to be that. We can capture that as we prepare to go on to look for the angle of emergency for the violet light. To look for the angle of emergency for the violet light. Yes, this airtime is for the candidates and any S5 students that are following this lesson to capture the first part solution for this number. Remember, the key word in the question was minimum deviation. You must know that at minimum deviation, the deviation on the first face plus the deviation on the second face should be rounded off to be equal. In other words, the value of I1, which we normally call I1, and the value of I2 are normally assumed to be equal, and the value of R1 and the value of R2 are also assumed to be equal, and therefore, when you merge the two, you get what we call minimum deviation at the condition where I1 is equal to I2 and is equal to I, and R1 is equal to R2 and is equal to R. Then we get what we call minimum deviation. In other words, on the prism, the light ray is supposed to be expected to pass normal to the base of the prism. It should be parallel to the base of the prism at minimum deviation. If you are taking a picture, I would expect that you have already captured the part 1 solution for this number. Let us move to the part 2 of this number. Part 2 is for the violet light. We have one important fact now, that we know the value of I. The value of I here we know, and this is 49.24 degrees. And they want us to find that if this light is refracted and it emerges here, they want us to find the angle of emergency. Remember, this is 60 degrees. This, I can call it R1. This, I can call it R2. According to the angle geometry, this is 60 degrees. And we want to find this. Assuming I call it E. If I call that angle E, we are aware that we are dealing with violet light, and the refractive index of violet light has been given as 1.529. So if we use n sin I on this face, I'll call this point A and this point B. Refraction at point A, we shall get air, and air, the sine of 49.24 should be equal to, this is violet light, to n violet, the sine of what I have called R1. And since our interest is R1, R1 will become the arc sine of the sine of 49.24 degrees divided by 1.529. If you compute that, it should be able to give you R1 approximately as 29.69 degrees. If you compute that, your R1 should be that. Using R1 plus R2 to be equal to the refracting angle, it further implies that our R2 will be 60 minus 29.69. And therefore, our R2, when you do the subtraction, should be approximately 30, should be if we do the subtraction, $30.31. Our R2 becomes that. If we consider refraction on face B, refraction at point B in a similar way, we shall have n sine of R2, that's n violet light sine of R2 should be equal to n of air, the sine of E, and we will have 1.529 times the sine of R2, which is 30.31, should be equal to 1 times the sine of E. So the value of E similarly will be the arcsine of this. If computed, will give us 0.7, approximately 7715, and will give us finally a value of E as approximately 50.49 degrees. So we can say, therefore, angle E, emergence angle E is equal to 50.49 degrees. Is equal to 50.49 degrees. The emergence angle is 50.49 degrees. In the remaining time, I want us to look at an expression for deviation by a small prism. Deviation by a small angle prism. This is a very common expression that we shall eventually obtain as that. It falls under lenses, and usually we call these thin lenses. But because a thin lens is considered to be a prism, we are going to look at this. Thin lenses are regarded to be made up of small angles, small angle prisms that are normally packed on top of each other. Illustrated, if we consider this as a lens and you divide it up, you clearly see that the top part is a prism whose refracting angle we can call A. Or if we consider this kind of lens that is diverging, if you joined up this part and actually this lower part, you'd form a prism whose refracting angle we can still call A. Now, we want to derive an expression for the small angle deviation. And therefore, I will put that sketch here so that we can ensure that we are able to get through this derivation in the time that is expected before our lesson for today ends. If we consider this as a simple sketch diagram for what we are interested in finding, we know that when we extrapolate this, the deviation here is d1, and when we extrapolate this, the deviation here is d2, and this is the total deviation. For a ray incident as indicated, if I call this A, B, C, D, if we consider that as a ray incident there, and we consider refraction at B, if we consider refraction at point B, the ray is from air, so it is n air. The sine of I1 should be equal to n for the prism, I'll call it that, the sine of R1. Since n air is 1, it implies that the sine of I1 is n the sine of R1. But we are dealing with small angles. So for small angles, the sine of I1 is approximately I1, and so is the sine of R1, approximately R1. This implies that this expression I1 becomes nR1. I call that A. If we consider refraction at C, in a similar way, we will be able to get the same, that n, the sine of R2, should be equal to n am, the sine of I2. For small angles again, the same applies, that n R2 is actually equal to I2. Now, since we are aware the total deviation from our previous discussions is the deviation on the first face plus the deviation on the second face, I will be able to get my deviation d1 as I1 minus R1, and deviation d2 is I2 minus R2. So if we add them up, we have I1 minus R1 plus I2 minus R2. But remember that if we correct like terms, I1 plus I2 minus into R1 plus R2 is what we shall get over here. But we have I1 and I2. So if I substitute for I1 and I2, we should be able to get home and dry very soon. In this equation, substitute for I1 and R2. I1 and I2 in star. If I do that, my D will become my I1, which is nR1. My I2 is nR2, and I am taking away the sum of R1 plus R2. If I do the factorization, I have the n into R1 plus R2 minus R1 plus R2. But our R1 plus R2 from this triangle is A. So my D will be equal to R1 plus R2, which is a common factor, into n minus 1. If I substitute for R1 and R2 as A, I will therefore get my D as A into n minus 1, which is the expression for the deviation for a small angle prism. As we wind up today's lesson, I want to leave an assignment for students to read about how to use a prism spectrometer to measure refractive index of a prism and how to do the adjustments of the prism spectrometer in that experiment. I want to thank you for always attending these lessons. Wish you a nice weekend and wish you a good preparation as we wait for the school opening. God bless you. Gachali Mabaga.